How about ozone? Ozone is O3. Okay, it's got 3 O's in it, so there's no real middle atom here to go with. They just all go in a line. So we have 1, 2, 3. Okay, so each O has 6 valence electrons. You know what I'm going to do? I'm going to put the middle one with red dots. 1, 2, 3, 4, 5, and 6. And then five and 6. Okay, so everybody needs 8 here, right? So just start bonding unpaired electrons to each other. So how about those two? How about these two? All right, so that gives me that gives me this. I'm going to draw as a single bond. A single bond, and I have one unpaired on the bottom on the left O here and on the right O too. And I got those 2 red electron pairs on the middle O. Okay, so I've got 2, 4, 6, 7 electrons on this left O here. I've got 8 on the middle, 2, 4, 6, 8, and 7, 2, 4, 6, 7 on that. So that's a problem. What do we do? This one's harder, as you can see. So what we're going to do is, what if we pair these up, first of all? Let's get these unpaired electrons paired up. Just put them right here. Okay, so now this left O here has 2, 4, 6, 8 electrons around it, and so does the middle O, but this right O has 2, 4, 6 electrons around it. So what do we do? Well, what if we go like this? And this is kind of trial and error. When you're doing it, you may have to erase a lot and just try something else. But what if we just put this electron pair here? In here is a double bond. I can't put it in here as a double bond because I'll overload this O with too many electrons. We have to keep it at 8, 2, 4, 6, 8. So this guy's only got 6 though on the right side. So let's try putting it in there. So I have I'll just show it as a red line, those 2 electrons, and then we have the 2 dots up here. Okay, now, are we okay? Do we have the octet rule satisfied for everybody? Well, this oxygen has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. And this oxygen has 2, 4, 6, 8. And that's good. So that's it. That's the answer. And I just wanted to mention something about what's called a resonance structure. Why do these 2 oxygens have a double bond and these 2 have a single bond? Well, this double bond is actually delocalized. 2 of these electrons are actually moving between both O's, this O and that O, and this O and that O, at the same time. Okay, and the way to show that is with a double-headed arrow like that, and to move the double bond to the left. In this molecule, because we have an electron pair in the middle atom there is actually bent also. So I moved the double bond to the left, and now this one has two unpaired electrons, and the single bond is here, and this O has three unpaired electrons. These are called resonance structures, and there are two of them for the ozone. Okay. Okay, so that O3, the ozone molecule, was pretty messy to do that Lewis structure, or electron dot structure. Is there an easier way to do molecules? And the answer is, of course, yes.